because here we have assumed that the diode is ideal, so that's the reason both systems are linear. But if the diode is not ideal, then the other system will be non-linear. And here the systems of equations are linear in the end, but there are two different systems of equations. So that's the reason. That is the reason behind it being called
variable structure. No, first of all, non-linear is with respect to the fact what is the definition of a linear system. That superposition and non-linearity. The moment you have a diode or a BJT in a circuit, that the bidirectionality property is lost. That means that you can no longer apply the superposition property. That is the reason why it is non-linear. But it is a specific type of non-linear system, that is individually it gives you linear. So that's why it is a separate category, switch linear system. It is not that, suppose if you have x dot equals to minus x square, it is always non-linear relationship. No, first that I am coming to your second point. That is what he said, that is correct. That is diode. If here we are considering ideal diode, the resistance 0. That is the reason why individually they are becoming LTI. Otherwise, this also, that is, we may not be able to consider that this is linear. But because of due to the presence of a diode or a BJT, bidirectionality property of the current is lost. That's why we cannot apply the superposition theorem. I'm giving you another simple example. There is in our first year electrical engineering, we used to solve this kind of circuit, and in the lab, that is, you were supposed to show that is IL, that must be IL1 plus IL2. IL1, that is, there is only V1, IL2 means there is only V2, right? So why that works? Because the circuit is linear. Not only that is linear, here the current, it has the bidirectional property. There is two-port bidirectional network, right? Now, that is, if I add, suppose I add a diode over there. Now, can you apply the superposition